here we cannot do 0 minus 1, so we borrow a 2 from here, but the third place or the fourth, let's say, don't have what to give to this place here, but they borrow from the last one, from 1. So this is distributed into all these place values here. So we write 2 minus 1, it is 1. Here we had 2, in fact, when it has been borrowed from here, but it remained 1 because one of them has been given to 2's. So we have only 1 4 left. 1 minus 1, it is 0. Here it is 1 now, and it is 1 as well, and it is 0 because this number, this one, has been distributed into all the other place values here. So we have 1 minus 0, let's say. We can fill with 0 the empty places. 1 minus 0, it is 1, and all. So we have 1 here, and 1 minus 0, it is still 1. And the last value will be 0. I will not write it at all. So therefore, you got a correct result. Both of you gave the same answer. That was 11011, and it corresponds to the correct answer here. So I will not try to do the proof because all of us know that this is correct. Now let's start with the multiplication. The multiplication is similar to the multiplication of decimals. So basically, I'll start with the multiplication of decimals first. Let's try to do this. 257 times 32, for example. We have 2 times 7, it is 14. We have 4, and 1 is carried here. 2 times 5, it is 10, plus 1, it is 11. We have 2 times 2, it is 4, plus 1, that is carried here, it is 5. The same thing, we can fill with 0 that place because we should start from the second row, from the second column. We have 3 times 7, it is 21, 1, and we carry 2 here. 2 times 5 times 3, it is 15, plus 2, it is 17. 7, and we carry 1 here. And we have 3 times 2, 6, plus 1, because now we cancel those numbers because they were for the first multiplication, not for the second. So we have 3 times 2, 6, plus 1, it is 7. The result will be 4 plus 0, it is 4. 1 plus 1, it is 2. 5 plus 7, it is 12, and we carry 1. 1 plus 7, it is 8. The same thing is also true for binary numbers, but in binary numbers it is easier than in 10 base number system because we don't have to carry anything. We have only 2 possibilities. Either we have 1 times 1, that is 1, so we don't have to carry anything, and 1 times 0, or 0 times 1, or 0 times 0, all of them give 0. So it is easier than in 10 base 10 number systems. Let's see an example of multiplication with binary numbers. If I have 1 0 1 1 times, let's say 1 1 0, approach is very similar to that one used previously. So we have 0 times 1, it is 0. 0 times 1 again, it is 0. All of them are 0 in the first row because all these numbers are multiplied by 0. Now we should start from the second column. So we can put a 0 here and then starting from here. So we have 1 times 1, it is 1. 1 times 1 again, it is 1. 1 times 0, it is 0. And 1 times 1, it is 1. Now we should use the third column. So the first two we can fill with zeros and start from here. 1 times 1, it is 1. 1 times 1, it is again 1. 1 times 0, it is 0. And 1 times 1, it is 1. Now these numbers are to be added with each other. We have all 0 here, so the result is 0. We have only a 1, so we should write 1 only. We have 0 plus 1 plus 1, it is 2, but we don't write 2, but we write 0 because we carry a 2 here. So we have 1 plus 1, 2 again. So again, we write 0 and we carry 1. And 1 plus 1, it is 2. Again, it is 0. And we carry again 1 here. 1 plus 1, it is 2, but we don't have to carry anything anymore, but we simply write 0 and 1. So the result is this number. Let's check it by making the same multiplication but with decimal numbers. So to convince ourselves that we did the right thing. Now this number corresponds to 1 plus 2, so we start from right to left. 1, 2, 0 fours and 1 8. So 1 plus 2 plus 8. The result is 11. For the second number, we have 0 ones, 1 2 and 1 4. So for 2 plus 4, it is 6. And the multiplication of 11 times 6, it is 66. Let's check whether this number is 66 or not. So we have 0, 0 ones, 1 2, 0 4s, 0 8s, 0 16s, 0 32s, and 1 64. 2 plus 64, and the result is 66. So we got the same result in both cases. So that approach or this way of solution is correct. So you should only take care about the carries here, but not at the beginning. During the multiplication process, there is nothing to carry, but when we have to add the results, then maybe we can carry anything. So did you understand? Are you ready for a classwork or not? Or you want to make another solved example from me?
I'm ready for...
Yes, please.
Okay. So you want a challenge now?
No.
Or not? Okay. Yeah, I'm explaining another. Maybe you will be sure. I'm doing a shorter one. We have 101 times 10. This is much shorter. So we start from here, from 0 times 1, it is 0. 0 times 0, it is 0. And 0 times 1, it is 1. We fill with 0 that place because we are starting from the second column here. So I have 1 times 1, it is 1. 1 times 0, it is 0. 1 times 1, it is 1. Now we have to add, in this topic, are combined addition and multiplication, so two operations in binary systems. So we have 0 plus 0, it is 0. 0 plus 1, it is 1. 1 plus 0, it is 1 again. And we have another 1 here. So the result is this number. I am not writing anymore the base because we are aware that we are discussing about numbers with base 2, but I'm only checking the result. This number in the 10 base system corresponds to 1 plus 1 1, so it is 1 plus 0 2 plus 1 4, it is 5. 5. This number is the number 2 because it is 0 ones and 1 2. It is 2, so if we multiply 5 and 2, the result will be 10. 10 I will write inside the brackets to not confuse with binary numbers. It is 10 at base 10. Now let's check the result here. We have 0 ones, 1 2, 1 4, and 1, no, sorry, 0 ones, 1 2, 1 4, and 1 8. 8 plus 4, 12. I must check again the result, what I did here. 5 times 2, it is 10. But the result is 0, 1, 1, and 1. So this is 0 plus 2 plus 4 plus 8. 8 plus 4, 12. Plus 2, it is 14. Oh, so I have to check again what is the issue. 0 times 1, it is 0. 0 times 0, it is... so this is the issue. This should be 0 because 0 times 1, it is 0. So I have a 0 here. So the result is 8 plus 0 plus 2, or 8 plus 2, it is 10. So these numbers are both the same. Now I think you are ready, or not yet, because I want to explain also the not whole numbers written in decimal system today. I don't want to leave it for the next time. Next time I'll explain other things. So for you, I have this exercise. Multiply 1 0 1 1 times 1 0 1. I don't think I did it before, so it is new for you. You can do it in just 4 or 5 minutes. You have time to do it in 4 minutes, let's say. Be filled with 0, but actually in multiplication it is not suggested to fill with 0 because you can confuse the order. So let's leave it as it is for the moment. And when the time to do the addition comes, then we can fill with zeros those empty places. So I prefer to leave it without adding the 0 to keep the order of let's say operations. Now the third row will start below the third column from the right. So we have to repeat again this number because it is multiplied by 1. I should write four numbers here, and they will be the same as the first number written in the multiplication. So we have again 1, 0, 1, 1. Now that the time for making the addition has come, we can fill with zeros those empty places to make the operations easier for us. So we have 1 plus 0 plus 0, it is 0. 1 plus 0 plus 0, it is still 0. We have 0 plus 1, 0 plus 0 plus 1, it is, sorry, 1 plus 0 plus 0, it is 1. Again, 1 plus 0 plus 0, it is 1. 0 plus 0 plus 1, it is 1 again. 1 plus 0 plus 1, it is 2. We cannot write 2, but we write 0. And we carry 1 here. 1 plus 0 plus 0, it is 1. And we have another 1 here. So the result will contain 6 digits that are all 1 except the third, let's say, from the left, or the fourth from the right. But now we are going to make the proof, because we are going to convince ourselves that our solution is correct. This number corresponds to 1. We start from here to go from right to left. 1 plus 2 plus, we don't have any 4 here, so we have an 8 plus 8, it is 11. This number is 1 plus 0 2, but 1 4, 1 plus 4, it is 5. And we know that 11 times 5, it is 55 in the base 10 number system. Now we should see whether this number is 55 or another number. Normally it should be 55, but we are going to check it. So we have 1 plus 2 plus 4. We don't have any 8 here, but plus 16. Plus 16. This was the place value of 16s, and this is the place value of 32s. So we have plus 32. Let's see the result. 1 plus 2, it is 3. Plus 4, it is 7. Plus 16, it is 23. Plus 32, it is 55. Did you understand the multiplication of decimals of binary numbers? Is there any difficulty in understanding? Because the procedure is the same as in multiplication of normal numbers, so it is not difficult to understand as logics, but you should only observe the correctness of your operations. That's all. Now, another thing to discuss for today is how to write let's say non-whole numbers when they are written in decimal system as a binary, but not every base 10 number system, when it is not whole, can be written as decimal. Only some of them. And more specifically, we can use a decimal point or a decimal comma, like in the normal numbers. Let's write first a normal number, 75.8. What does it mean? That means that we have 5 ones plus 7 tens and plus 8 times 1/10 or 8/10. This is the meaning of this number in decimal system. So we have 7/10, or in a more scientific way, we can write 7 times 10 at power 1 plus 5 times 10 at power 0, because we know that every number at power 0 is 1, plus 8 times 10 at power minus 1. Do you know from the school that when numbers are written in this way, so with the denominator is 10 or 100 or 1000, and we want to write them as a sign in a scientific form, so in this form here, the power is negative, the exponent is negative. Do you know from the school this fact or not? So
No.
okay, so I will explain a short thing about decimal numbers, about, let's not decimal, but yes, decimal when written at a decimal comma, but let's say if the number is written as a fraction, this number 1/10, what does it mean? This means that we can write it as 10 at power minus 1, because the power is here. But if we want to change the place of the number 10 from the denominator to put it in the numerator, because we can divide it by 1 as well, it is not a problem to divide by 1, we should change the sign. It is a long story to explain. Maybe if you don't know this, I can explain the next time. I can start from powers and exponents to explain why this is true. But for today, it is enough for you to know that if we want to write the fraction 1/10, it is written as 10 at power minus 1. Or if you want, you can forget this part here and focus only in this part here, because the same thing or the same, let's say, approach can be used to write the decimal, not whole binary numbers. We can write the number, for example, 101, 10, and the meaning of this number is as follows. This represents the ones, so we have 1 times 1, let's say. This represents twos, we have 0 times 2. This represents fours as usual, so we have 1 times 4, and they are to be added with each other like here. But what happens with the part after the or on the right of the decimal place? They are written as, the first one is written as 1 times 1/2. The second, okay, I'm adding another one here. So the first one is written as a number 1, the coefficient 1 times 1/2, but the second is 0 times 1/4. So we get the inverse of the numbers that are on the left of decimal place. When we are going to multiply the coefficients, the numbers here, with the corresponding value, when we are going to convert them in the base 10 number system, we obtain the inverse of these numbers here. So plus 1 times 1/8, because we have 1/2, 1/4, 1/8, like here, that we have 1, 2, 4, 8, 16, etc. Now we have 1 over that number. So the base 10 number that corresponds to this number written in the base 2 system is 4. I'm not writing 0, but I'm writing 1 here. 4 plus 1 plus 1 over 2. I am not writing 1 over 4 here because the coefficient is 0, so but I'm writing 1 over 8. And therefore, the corresponding base 10 number of this one is 5 plus, we can find the common denominator here, that is 8. So the number 2 is multiplied by 4 to get 8. So we have 1 times 4, it is 4, plus 1. And the result is 5 plus 5 over 8. We can write 5 over 8 as a decimal by dividing 5 and 8, and we get 0.625. So it is equal to 5 plus 0.625. Therefore, the result is 5.625. So this is the answer, or the conversion of this number into base 10 system. It is a bit complicated when you heard it for the first time, but I'm sure that with 1 or 2 practice exercises we will learn it very well. Do you understand as a logics first? Logically, do you have any issue to understand? I'm not speaking about the mathematical procedure, but only as a logics. Are you clear? What does a binary number with a decimal comma in between represent? Can you try very fast to convert this number 0.11 to write this number, write this one as decimal. Write this one as decimal. This is the demand. If you can do it for just 3 or 4 minutes, it would be great. If not, no problem. We can explain again the next time for 10 or 15 minutes at the beginning of the lesson. Oh, sorry. I